All right, guys. So the probability questions that we saw yesterday, that you've been seeing since you're like the 7th grade, with what's the probability of picking a yellow marble out of a bag, or a name out of a hat, or a card out of a deck, or rolling a dice. In the whole grand scheme of things, those probabilities don't even matter. Okay, they're going to impact life somewhere else, right? Now, there are some things that we learn from that we can use in kind of higher level mathematics and higher structured kind of systems that we use mathematics within, like scheduling and those types of things. We can use probability and the idea of picking marbles or names or something like that to be of benefit to us. But probability that you guys are probably most impacted by, or that you see on a regular basis, are things like this, okay? Where we do we do what we call actual research, okay? Where you create an experiment, you collect data on that experiment, and then you let that data either verify or negate maybe a hypothesis that you develop, okay? You guys know what a hypothesis is, right? Okay, in science, like you make a decision that this is the situation that's going on, this is what's happening, and then through research we come up with data that either supports that or does not support it, okay? Where you guys see probability the most is probably in regards to maybe pharmaceuticals. You guys know what pharmaceuticals is?
Yeah, drugs.
Okay, so drugs, right? Okay, like medical drugs, okay? If you watch a commercial, okay, we're talking about, I think it's Opdivo, which is I think it's a medicine that prolongs the life of people with lung cancer, okay? I think. Could be completely wrong. But if you watch a commercial like that, they'll give they'll do the advertisement and they'll say that, they'll show all these cheery people and living longer and stuff like that. But at the end, for like 30 seconds, the guy reads real fast that you're going to get diarrhea, stomach aches, headaches, migraines, you're going to go blind, lose hearing in your right ear, and all that kind of stuff, right? Okay. So they give all these side effects, right? Okay. Does that mean every time that I take that medicine, every person is going to get those side effects? No. Okay. What the FDA is, you guys know what the FDA is?
Yeah.
What?
Federal Department of Agriculture.
Or the Food Drug Administration. They set standards. They set standards that says within research, there might even be other kind of agencies that allow this and kind of work together with the FDA. But they set thresholds that say if you sample 1,000 people in your research, okay, if you provide in a study treatment with this new drug to 1,000 people, if 1%, if 1% of those 1,000 people experience a side effect, then you have to report it. Okay, it has to be in your marketing. So let's say, what is 1% of 1,000? 10. So that means that if 10 people throughout the study get diarrhea, we have to report that as a side effect in our ad, right? So if 9 people in this study went blind or died, okay, because maybe that's a side effect, do we have to report that?
Yeah.
No. In good conscience, maybe you do, but you don't have to. A lot of times you see with medicines that say, side effect is potential death, right? And they say that. But that's with anything, okay? But that's all probability. So they're giving you that data so that you can make a decision as a consumer. Am I willing to take that risk? Am I willing to, maybe cure the ailment that I have now, but live with chronic diarrhea for the rest of my life? Okay? Those are decisions you have to make.
You mean like dysentery?
Now, if you have does anybody understand how the whole process of determining whether a drug is effective or not works?
Yeah, I haven't more than
Okay, so this is what happens. We have an ailment, right? We have an illness, a disease, a cancer, something like that, and we design a drug to attack it, correct? And to cure it or to at least halt its taxing or taxation on the person, right? Okay. That process involves obviously making the drug and then doing experiments with it, right? Research experiments. So we create a group. We look for people that are willing to take experimental treatments. Okay. Yes.
Is this one that like you give people the drug and don't and like consider them?
Yes. Yes. So we create this drug. We get this research group. Okay. People sign up for it. Okay. And what they do is they create what we call a controlled group. Okay. And then they create a variable group. The variable group is the group that they're going to give the drug to. Does that make sense? The control group is the group that is, we're not going to do anything with them except for give them a placebo. You guys know what a placebo is?
Yeah, I think I'm fake.
Okay, so it's ultimately, a lot of times it's just maybe a vitamin, but a lot of times it's just a water pill. Okay? But the mind, okay, when you take a drug that you think is going to make you better, that psychological effect will actually stimulate chemical responses in your body and your mind that may indeed kind of impact your illness. Does that make sense? And they might even cure you of your illness. So what they do is that they, through a study, they'll go maybe, let's say, 3 months in a study where they're giving one group just the placebo. They don't know it. Okay, they're just getting the placebo. The other group is getting the actual drug. And then at the end of this 3 months, they're going to compare the health of the group that got the placebo and the group that got the actual drug. If the data shows that there was actually, at the end of those 3 months, there's no difference between the two groups, so the people in the first group that got the placebo and the people in the second group that got the drug, if their health is the same, basically, that tells me that the drug was as effective as water. Does that make sense? Okay. If there's a drastic difference, it tells me there was a particular effectiveness of that drug. Does that make sense, everybody? So then we continue maybe to do more studies and more research on that, and then we market that drug for curing that ailment. Okay. The thing to understand, though, is that the larger your sample space is, the more accurate and more telling your data is. Think about it. You see commercial says 9 out of 10 dentists recommend this toothpaste, right?
Is your dad?
Okay.
I don't know. That's what he said.
Well, I thought his dad was a vet.
Orthodontist.
Okay.
But he does some dentist stuff. No, I always ask my dad that, and he says, okay.
Well, who do they? So at the bottom of the screen, when you see these types of things, when they give you data or statistics like that in commercials, bottom of the screen, it will say, we surveyed this many people. Okay, this many dentists. Well, if they only surveyed 10 dentists, and 9 of them said, yes, this is good, am I willing to make that risk? Because half of your dentists fall at the bottom of their class, don't they? Does that make sense? Yes, no?
What?
Half the dentists are bad dentists, right? The other half are good dentists. Does that make sense? Half your doctors are good doctors, half your doctors are bad doctors.
Half teachers are good.
Half teachers are good, half teachers are bad. Okay?
Good means bad.
So if they're surveying only 10 people, maybe they surveyed 10 terrible dentists, right? Okay. Now if it says 9 out of 10 dentists recommend this, but we surveyed 1,000 or 10,000 dentists, now is that 900 or 9,000 dentists that said that this is good, this is a quality toothpaste? Is that a little bit more reassuring to you as a consumer? Okay. So when you guys read statistics, when they come across the news and they talk about statistics for politicians and stuff like that, see what that data, what that stat is coming from, who it came from, what their prerogative is, what their agenda is, what they're trying to push to you, because those stats and those probabilities that are provided there are very telling if you investigate their formation, where they came from. Okay? Yes?
So the whole, giving people, the placebo and then it's like, oh, I'm magically fine again, is that the whole, African warlord, grinding rhino bones thing? There's oh, I'm just going to grind and, these rhino bones will magically cure, HIV.
I mean, maybe, that might have part, apothecaries and stuff like that. That might have, some validity to it, but, obviously, most of our medicines are found through nature in flowers and plants and stuff like that, and,
not ground rhino bones.
Maybe. right, here we go. So that discussion, guys, is trying to get you to see that when the end-of-course exam is written and when you're dealing with probability in real life and in a useful situation, it's not going to be what's the probability of picking a red ace out of a deck of cards, because that's meaningless. But it might be useful to talk about probability in regards to like clinical studies and stuff like that for drugs and treatments and those types of things. Okay. This question here says, in a sample of 50 people, okay, 21 had type O blood, 22 had type A blood, 5 had type B blood, and 2 had type AB blood. Okay. Now here, this is called a frequency distribution table. What does the word frequency mean?
How much it goes up and down?
No.
Does it say your blood type on your like driver's license?
I don't know. Let's talk about things that are important. Okay. Frequency distribution. What does frequency mean? How many times it happens? How many times it occurs? Distribution means what? Okay, when we define something, we don't use the word or a derivative of the word in that definition.
What does 12 graph mean?
Frequency distribution. What's distribution mean?
To give out.
Okay, to give out, to spread out, right? Okay. So when we talk about frequency distribution, we're talking about how spread out these blood types are, or these characteristics are. Does that make sense? These 50 samples are spread out amongst 4 different types. Okay. We want to see how often. So when we go through this and list this, it says type A has a frequency of how much? How many times does type A occur?
22.
22. Okay. So 22. Type B occurs how much?
Type what?
Type B was 5. AB is 2. And O was 21. All right. So that's our frequency distribution. That total should be equivalent to my sample space. Okay, if I add 22 plus 5 plus 7 plus 21 gives me 50, matches up to what the initial sample space should have been. Okay, if I would have a number that was different than 50 there, then I would have a type of blood, a frequency of somebody having a particular blood type that was not in my sample. So I'd have a phantom person. Does that make sense? So we need to make sure that doesn't occur here. So now, this is called a frequency distribution. What I need you to understand is that when we're doing probability, there are a lot of questions we have to ask ourselves before we actually start doing the number crunching. And one of our major questions you have to ask is, are these events what we say to be mutually exclusive? Okay, and we'll define this here in a little bit. We ask ourselves, are these events capable of happening at the same exact time? Okay, mutually exclusive events say that they cannot happen at the same time. And that's what we are interested in. So can you be a person that was marked as being type A? You have type A blood. Can you then be a person that's marked as type B? No, you cannot. Okay? If you're type A, you are type A. If you're type B, you're type B. If you're AB, then you're AB. It's not that you're B or that you're A, you're AB. Does that make sense? Okay? If you're a freshman, you're marked as a freshman, you're not a sophomore. If you're a sophomore, you're a sophomore, you're not a freshman, you're not a junior, you're not a senior, right? You cannot be a sophomore at the same time you're a senior, a junior, or a freshman, right? So your classes are mutually exclusive. They cannot happen at the same time. Make sense? So A, B, and O are like classes. You cannot be in both classes in this situation at the same time. Questions on that? Yeah.
Isn't O blood like the universal?
Okay, so O blood, you're compatible with all those, but that doesn't mean you're A. That means you're O. Does that make sense?
You can only say O, but you can get.
Okay. So, I don't know how it works, but you cannot be categorized as O and also be categorized inside A. Does that make sense?
Yeah.
You might be compatible with A, but you're not categorized as A. On your license, it says O. It does not say A. It does not say B. It doesn't say AB. It is if you put it on there.
There was the letter A on my.
Now the question is, the reason we have to talk about this, so those things cannot happen at the same time. That's very important. Okay, so if If Mr. Fay is in type A, and marked in one of those 22 frequencies, he is not in the 5 frequency, the 2 frequency, the 21 frequency for the other classes. Okay? That's very important for us to understand. So we're going to answer these questions here, A through D. It says a person has type O blood. What is the probability? What is the probability that you have type O blood? Okay? Well, if you remember from yesterday, having type O blood